Online deployment is a critical phase in the life cycle of a machine learning model. It involves making the model available for real time predictions, allowing users or systems to interact with it over the internet. This process ensures that the model can be accessed and utilized efficiently, providing immediate insights and decisions based on new data. In this presentation, we will explore the various settings and configurations required to successfully deploy a model online, ensuring it operates smoothly and effectively. Proper configuration of settings for online deployment is essential to ensure the model performs optimally. Incorrect settings can lead to issues such as slow response times, high operational costs, and even model failure. By carefully configuring the deployment environment, you can enhance the model's performance, scalability, and reliability. This involves setting up the right infrastructure, managing resources efficiently, and ensuring security and compliance. Selecting the appropriate infrastructure is the first step in configuring settings for online deployment. This includes choosing between cloud-based solutions, on-premises servers, or hybrid environments. Cloud platforms like Azure, AWS, and Google Cloud offer scalable and flexible options, while on-premises solutions provide more control over hardware and security. The choice depends on factors such as budget, scalability needs, and specific use cases. Compute resources are the backbone of any online deployment. Configuring these resources involves selecting the right type and size of virtual machines, VMs, or containers to run the model. Factors to consider include the model's computational requirements, expected traffic, and cost constraints. Autoscaling features can be enabled to adjust resources dynamically based on demand, ensuring optimal performance and cost efficiency. Networking and security are crucial aspects of online deployment. Proper network configuration ensures that the model can communicate effectively with other systems and users. This includes setting up virtual networks, subnets, and load balancers. Security measures such as firewalls, encryption, and access controls must be implemented to protect the model and data from unauthorized access and cyber threats. Data storage and access configuration are vital for the smooth operation of an online deployment. This involves setting up databases or data lakes to store input data, model outputs, and logs. Ensuring fast and secure access to this data is crucial for real-time predictions. Considerations include choosing the right storage solutions, implementing data redundancy, and setting up access controls to manage permissions and security. Monitoring and logging are essential for maintaining the health and performance of the deployed model. Setting up monitoring tools helps track key metrics such as response times, error rates, and resource utilization. Logging provides a detailed record of the model's operations, which is invaluable for debugging and performance tuning. Tools like Azure Monitor, AWS CloudWatch, and Google Stackdriver can be used for these purposes. Continuous integration and continuous deployment (CI/CD) pipelines automate the process of deploying updates to the model. This ensures that new versions of the model can be tested and deployed quickly and reliably. Setting up CI/CD pipelines involves configuring version control systems, automated testing frameworks, and deployment scripts. This reduces the risk of errors and downtime, ensuring the model remains up to date and functional. Scalability and load balancing are critical for handling varying levels of traffic and ensuring consistent performance. Configuring autoscaling policies allows the deployment to automatically adjust resources based on demand. Load balancers distribute incoming traffic across multiple instances of the model, preventing any single instance from becoming a bottleneck. This ensures high availability and reliability, even during peak usage times. Optimizing performance and cost involves fine-tuning the deployment settings to achieve the best possible efficiency. This includes selecting the right instance types, configuring autoscaling policies, and optimizing code and algorithms. Regularly reviewing and adjusting these settings can help reduce operational costs while maintaining high performance. Tools like cost management dashboards and performance profiling can assist in this process. Compliance and governance are crucial for ensuring that the deployment adheres to legal and regulatory requirements. This involves implementing policies and controls to manage data privacy, security, and ethical considerations. Regular audits and compliance checks should be conducted to ensure adherence to standards such as GDPR, HIPAA, and other relevant regulations. Proper documentation and reporting are also essential for maintaining transparency and accountability. To illustrate the concepts discussed, let's look at a case study of a successful online deployment. A retail company deployed a recommendation engine using Azure Machine Learning. They configured scalable compute resources, implemented robust security measures, and set up CI/CD pipelines for continuous updates. By monitoring performance and optimizing settings, they achieved a 30% increase in sales and a 20% reduction in operational costs. This case study highlights the importance of proper configuration and management in achieving deployment success. In conclusion, configuring settings for online deployment is a multifaceted process that requires careful planning and execution. By choosing the right infrastructure, managing resources efficiently, and implementing robust security and monitoring measures, you can ensure the success of your deployment. Best practices include regular reviews and optimizations, adherence to compliance standards, and leveraging automation tools to streamline processes. By following these guidelines, you can maximize the performance, reliability, and cost efficiency of your online deployment.